Hello guys, how are you? I hope आप सब अच्छे हैं. So in the last video we have seen the electric field of the cylinder inside and outside. Now we are going to see the electric field of a charged non-conducting sphere in the inside and the outside, right? So let's start. So we have the field of a non-conducting. What is non-conducting? Non-conducting body is the body which is having a charge throughout this body, and the non-conducting bodies are having the charge only at the surfaces, right? So the field of a non-conducting sphere, right? It inside and outside, right? Outside. Okay. Now we'll see first of all outside. There we'll see outside. So we have a sphere of radius r, capital R. Okay. So now we have to find some random point. We'll take P here, and we have to find the field at this point. This body is non-conducting and uniformly charged. How? It is charged uniformly charged. Uniformly charged means either it is having lambda, sigma or rho. Lambda is the linear charge density, and the sigma is the areal charge density, and the rho is the volumetric charge density, right? So now what we'll do here, we cannot simply just apply the law and we can get the field. What we'll do here, actually we'll apply here the Gauss law. To apply the Gauss law, two things you have to see here. First of all, we have to make the full 3D geometry which is closed, and the charge should be kept at the center, right? So let's take this is a total charge, and we'll make one 3D object, 3D surface. It means we will take one sphere, right? We make one sphere, okay, of radius small r. Okay, because it's a 3D body, so we will take rho. Rho is what? Volumetric charge density. Volumetric charge density. Okay, in the last video I told you what is the volumetric charge density. You can see the last video and you can have a look on the volumetric charge density, right? Okay, so now and what will be the area of this outer sphere? This outer sphere, that will be 4 pi r square. Okay, and the volume of this sphere will be how much? 4 by 3 pi r cube. Okay, so now what we will do, let's take this is the charge inside, and we'll apply the flux on the outside boundary. I mean, we'll apply the flux, the Gauss law on this outer sphere. So we'll apply phi equal to, phi is what? This is the flux leaking out of any surface, is equal to Q inside by epsilon. Okay, if it is kept in this space, we'll take epsilon naught, right? And we also know that phi by the conventional formula it is E dot A, right? E dot A. Okay, if you take the field, how field will be generated? Like this. The field everywhere will be like this, in this direction. If you take the area vector of this outer sphere, how it will be like this. So this is the area vector, and this is field vector. It means, can you tell me what is the field? What is the angle between the field vector and the area vector? Obviously, these all are perpendicular to the outer surface. Either it is field, either it is the area. These all are perpendicular to the outer surface. So obviously, the angle between the area vector and the field vector is how much? It is 0 degrees. So theta here is equal to 0 degrees. Why? Because they all are in same direction. Okay. So if you open it, you can write EA cos 0 degrees. And what is cos 0? It is 1. So it is EA. Okay. Now, what is the charge then? This is the body. This is the sphere of radius r. So what is the total charge of this body? Obviously, total charge will be how much? Total charge will be volume into volumetric charge density. So what is the volume? It is 4 by 3 pi small capital R cube. Why we take capital R? Because we are finding out the volume of the inside cylinder, that is capital R cube into rho. Okay, so now put in the formula So we can say phi is equal to Q inside by epsilon is equal to EA, right? Keep the value of this 4 by 3 pi r cube into rho by epsilon naught is equal to E, and A is how much? 4 pi r square, right? Okay, so we can cancel the 4 pi and 4 pi. So what will we have now? E is equal to rho r cube by 3 epsilon naught into r square. Now you see here carefully, this rho is constant for a body, right? This r is also constant because it is the initial body, right? For this only we have to find the field, right? 3 is constant, epsilon naught is constant. So only this is the variable. It means this is the point. This is the point where we have taken the point. This is our point. This is the point where from the center. So the distance from the center of this point is r. So it means, can I say, is inversely proportional to r square. Okay, it means as we move away from the sphere, the field will decrease here, right? Okay. So now what? So shall I explain you once more time? So what we have done here, it is the initial sphere of capital radius r, radius capital R. Then the charge of this body is rho into volume. What is the volume? 4 by 3 pi r capital R cube, right? So now we apply the Gauss law. Gauss law is what? Q epsilon by Q by epsilon, and it is equal to E dot A, right? Area of the outer sphere is how much? 4 pi r square. So we will keep the values and we will get this value, and this is constant, this is constant, this is also constant, this is also constant. So obviously the E is inversely proportional to the r square. It means if we move away from the center of the sphere, the field decreases, right? Now we are going to see for the inside. Now we are going to see for the inside, right? So inside. So we have a sphere of radius capital R, and we have to find at some random point P, which is R distance away from the center. So what we will do again, we will make what? Sphere. Again we will make a sphere of small radius R. Okay. Okay. Now, so we will take the charge of this sphere only. I mean this imaginary sphere what we have made. So we again will apply the Gauss law here. The Gauss law is what? Phi equal to Q inside by epsilon naught. Now because we are applying the Gauss law on the inner sphere, so obviously we will take the area, outer area of the inner sphere. So what is the area of this inner sphere is how much? 4 pi r square, and the volume of this is equal to 4 by 3 pi r cube, right? And if you want to calculate the charge will be how much? Q inside will be, it will be the volume into volumetric charge density. What is the volume? 4 by 3 pi r cube into rho, right? And the phi is also equal to E dot A. Now you see here, the field will be generated like this, everywhere, like this. And the area vector of this is also like this. So obviously we can say here that the area and the field are in the same direction. So the theta will be equal to 0 degrees, right? So phi equal to EA cos 0 degrees. And what is cos 0 degree? It is 1. So EA, right? Now we are going to see phi equal to Q inside by epsilon naught is equal to EA, right? So if you write 4 by, what is Q inside? 4 by 3 pi r cube into rho by epsilon is equal to E into area is how much? 4 pi r square, right? If you see 4 pi and the square is cancelled here. So E is equal to rho r by 3 epsilon. Rho r by 3 epsilon. If you see here, you will find that it is constant, it is constant, sorry, this is constant, this also constant, and this also constant. So we can say the E is proportional to R. It means as we move away from the center of the sphere, the field will increase, right? And up to what point it will increase? It will increase up to the point where the periphery. Where is the periphery? So if you make the graph for the sphere, how we can make the graph for the sphere? See, this is the sphere, this is inside, and this is outside. This is inside and this is outside. So at the center, if you keep the value here in this formula, E is equal to rho R by 3 epsilon. If you keep R equal to 0, it means at the center R equal to 0 here. At the periphery, R equal to capital R, right? If you write R equal to 0, so field will 0. It means field here is how much? Field here is 0. Okay. If you keep the value R equal to capital R, it means at this point, so we will find E equal to rho R by 3 epsilon naught. So it is rho R by 3 epsilon naught. So it will increase. Inside it is increasing by linear relation. What is this relation? If you see the relation y proportional to x, it means what? Y equal to mx. How this relation is? This relation is like this. So okay. So again, the field will increase from 0 to linearly. It will go to rho R by 3 epsilon naught. Okay. And the relation here is proportional to R. Again, it will go like this from here. It is inversely proportional to R square. Okay. So up to here, up to the periphery, it will increase with the radius. After this, it will going to decrease. It is going to decrease. So I hope all of you understand this. So okay, we will meet in the next video. Okay, keep studying and stay safe in your home. Okay, bye. Thank you.